So let's see an example for candidate elimination algorithm. Here is an example. So in candidate elimination algorithm, we have to focus both positively contributing sample and negatively contributing sample. So initial hypothesis, we'll be focusing on both generalized hypothesis and specific hypothesis. In specific hypothesis, we have given all values null, and in generic hypothesis, we have given question mark. So here, instead of writing 6 question mark, I have given 6 times 6 question mark. The reason is we are going to identify which combination of attribute is going to contribute maximally to identify the right outcome. So let's get into the problem. So let us take iteration 1. In iteration 1, we have to check with the first sample data. So it is positive, right? The first sample is positive sample because the output label is having S. So it is a positive sample. So let us check. We will consider X naught as all the values: sunny, warm, normal, strong, warm, same. So these are all the values which we found in sample 1 as per the records. This is sunny, warm, normal, strong, warm, same. So we are saying it is a positive outcome because in output label we have yes. That's why we are concluding that is a positive sample. Now the thing is we have to check X naught with yes naught, because if it is positive, we have to start with the specific hypothesis. If your sample is positive, you have to focus on updating your specific hypothesis, and if the sample is negative, then you have to update the generic hypothesis, and during that time the specific hypothesis will remains the same as the previous iteration. In iteration 1, since it's positive sample, it will be updating the specific hypothesis and will be keeping the generic hypothesis as it is. So let us compare X naught with S naught. Since all the values are null, we have to replace the X naught value by default. As we already discussed this in the previous video in finder's algorithm. S1 is nothing but sunny, warm, normal, strong, warm, and same. So now the generic hypothesis is nothing but same as the previous hypothesis. Since it's positive, we will be updating only the specific hypothesis. And in iteration 2, we have to check the outcome, the second sample outcome. It is S here as per the table. So it is a positive sample. So if it is positive, we have to update the specific hypothesis and we have to retain the generic hypothesis as it is as the previous iteration. So here let me take X1 as the values of sample 2. So the attribute values are sunny, warm, high, strong, warm, same. So now the thing is I have to check with the previous specific hypothesis. Since it's positive, we'll be updating only the specific hypothesis. So X1 should be compared with the previous specific hypothesis. So here the first attribute value is sunny in X1 and it is same as S1. So S1 is also having sunny, X1 is also having sunny. So let us update the specific hypothesis, the same value. It is having the same value. If it has the same value, then you have to retain the value. And here in X1 we have warm and in S1 we have warm. The same value, so we'll be retaining it. And next we'll be having normal in S1 and high in X1. It is changing. So if it changes, as like we did in finder's algorithm, we have to replace it with a question mark because it is don't care value. And in X1 it is strong and in S1 the attribute value is strong. Since both are same, we'll be returning the value. And in X1 the next value is warm and the next attribute value in S1 is also warm, so we'll be returning the same value. And S1 last attribute value is same and X1 is also having the value same. Since both are same value, we'll be returning the same here. And for generic hypothesis, we'll not worry about the generic hypothesis. It is same as G0 or G1. Both are same. So and then let us check with iteration 3. So in iteration 3, we have to check whether the result, the sample is positive or negative. In iteration 3, the result is no. The output for this value, sample is no. So it is a negative sample. So if it is negative sample, then we have to update the generic hypothesis, and we should retain the specific hypothesis as like the previous iteration. So in iteration 3, then let us write the values of it. X2. So the third sample is having the value is rainy, cold, high, strong, warm, change, and that's all. So this is X2, the current iteration sample, that is third sample value from the given data set. So now the specific hypothesis retains the same as S2. In S2 we have sunny, warm, just like the previous iteration, strong, warm, and same. Now we have to update the generic hypothesis. Since generic hypothesis is still having 6 sets of 6 question mark. So we have 6 attributes, hence we have given 6 question mark. So now what we have to do is, we have to check with the values at first. What is the value of the third sample? It is rainy, right? It is rainy in X2. So first thing, you have to check with the previous sample's value from which the machine learned, and we have to identify the opposite values, that is other values other than rainy. What are the other values that are available in the data set, and that should be replaced here. Now we have done with 2 samples and we are in third sample. First we have to check with the first 2 sample values of sky, the first attribute, and check if there are any other values available over there other than rainy value. So other than rainy we have one value, that is sunny, which is opposite to rainy. So that should be written over here. It should be replaced, and all other are question mark. So I have done with the 5 question mark. So I have done with processed this single set. Still we have to process with other 5 question mark in generic hypothesis. And next we have to check with the second sample. Second sample is cold. Second value in the third sample is cold. So cold, we have to check with the previous 2 sample values. Is there any opposite value or other than cold values are available in the previously learned samples? So we have warm, which is the other value for cold available over there. So we have to replace it with cold here. And then third attribute is high. So we have to check with other 2 sample values. We have high and normal. So high is same as the third sample value. So we will leave it and we'll be replacing it with the normal value. So the third value is normal. Normal. Fine. And next is we have a strong. So strong should be matched with the other 2 samples, the previously learned samples. So it is having the same value. So we'll be placing it with the question mark. If the values are different, we will replace it over there. If the values are same, then that should be ignored. So here I am giving you question mark just for understanding. And here it is warm. So we have to check this warm with other values. Other 2 samples are also having the same warm. So I'll be writing 6 question mark. And next is change. So we'll check with the 2 sample values. It is having the other value, that is other than change, we have the other value called same. So that value should be replaced here. And same. So now I have done with the general hypothesis and specific hypothesis. Before proceeding to the next step, we have to eliminate the question mark. That is, already we are having full question mark set over there. That should be replaced here. We'll eliminate that. Fine. So iteration 4. Before moving to iteration 4, we have to check with the consistent data. What is consistent data? See, in iteration 3, we have a specific hypothesis and generic hypothesis. And in specific hypothesis, we have concluded that the third attribute, third attribute value, that is the humid attribute value, it is not consistent throughout the samples. See here in humid, we have first data is normal and the second data is high and the third data is high. It keeps on changing for the same output value S. In first sample, S output consists of humid value normal, and in second output, which consists of S sample, is having high value. So that is contradicting. Hence, we have changed that value as question mark in specific hypothesis in the previous iteration. So there itself we have concluded that this attribute is not contributing maximal for the outcome prediction. So in that case, we have to check whether that data, that attribute, third attribute have been included over here in the generic hypothesis. So first we have concluded with the sunny, and second attribute we have done with cold, right? And in third attribute, we have concluded with the normal and generic hypothesis, which should be eliminated because this is not considered to be a consistent data. It is inconsistent because in specific hypothesis in this iteration itself, we have concluded that this humid attribute can consist of normal or the value is high. So it is inconsistent, right? If it consists of question mark, you should not include that attribute over here in the generic hypothesis. So we have excluded all question marks and inconsistent data. So now in iteration 4, we have to check with the outcome. It is S, right? The outcome is S. So it is positive. If it is positive, we have to focus only on the specific hypothesis. So what is the value we have here? So in X4, so let's change this so that it will be easy. So we have X4, so sorry, X3. So in X3 we consist of sunny, warm, high, strong, cool, and change. So here we have to focus only on specific hypothesis because we have already confirmed with the positive sample. It is positive sample, so you have to update the specific hypothesis. So first you have to check with the previous iteration specific hypothesis with X3. So X3 equals S3. That should be checked. If the values are same, you have to retain it. If the values are different, then you have to replace it with a question mark. So the first value is sunny here. So in X3, and in S3 also we have sunny. If these two values are same, then you have to retain it, sunny. And in X3 we have the value as warm here, and in S3 the second attribute is having warm here, right? So the values are same, we'll be retaining it. And in X3 we have high, and in S3 we have question mark. So already we have concluded that as a inconsistent data. And the fourth value is strong here in X3, and S3 we have strong. Both are same, so we'll be retaining the value. And next value it is cool, and in S3 we have warm. So it is changing, so we'll be replacing it with a question mark. And last value in S3 it is same here, and in X3 it is change. It changes, it is not same, so we'll be retaining it with question mark. And G3 it remains the same because since it's positive sample, we'll be focusing only on updating the specific hypothesis and not the generic hypothesis. And here if the generic hypothesis, it retains with the same previous hypothesis. It is G4 equals G3. Let me write G3 here, sunny, question mark, and then cold, question mark, and then question mark, same. So this is the generic hypothesis. So here we have no other data to train the model. So since we are having the final hypothesis as S4 and G4, here in contrast to finders algorithm, in finders algorithm we have only one final hypothesis, but here we have the combinations of hypothesis, more than one hypothesis, which helps us to properly identify or correctly identify the outcome. So here S4, sunny, warm, and strong. The attributes which strongly contribute in specific hypothesis is sky, which is sunny, and the temperature, which is warm, and the wind, which is strong. These three parameters will strongly contribute for the outcome as yes. And from the generic hypothesis or final hypothesis, we will conclude that the sky equals sunny and temperature equals cold and forest equals same. These three parameters strongly contribute for predicting the outcome as yes. So this is how a candidate elimination algorithm works. Here you have to keep in mind that when you see positive sample, you have to compare the attributes, and you have to update the specific hypothesis. If the attributes are same, then it should be retained. If the attribute values are different, then you have to change it, update it as a question mark. And in generic hypothesis, if it is negative value, you have to update your generic hypothesis. And in generic hypothesis, it works opposite to your specific hypothesis. Here, if the values are same, you will ignore it. If the values are different, you have to replace it with the straight opposite value. Another question here is, if you have more than one value for the attribute while you are processing the generic hypothesis, then what you will do? There you have to consider both the values and you have to write it in the generic hypothesis. For example, if I have in sky the values as sunny, cloudy and then rainy, in that case while you are generalizing it for rainy, how you will write the generic hypothesis for first attribute? You have to write sunny comma 5 question mark, and then the next value is cloudy comma 5 question mark, right? So in that way, for first attribute itself, you will have two different values. So if you have more than one different values in the trained samples while you are processing the negative sample, then obviously you have to consider that for generic hypothesis. Thank you.